Alright, hey guys, welcome back to another episode of Stonks Maxing, day 112. It's currently 9:54 Friday, so getting pretty early, bright and early. I shouldn't say bright and early, it's like midday. But got my tie on, got my shirt on, ready to look at some stocks, write some stuff, and hopefully think. So with that being said, I'm gonna transition over to Discord. I'm on my large computer today, so I'm gonna do that and use that. But yesterday we left off the stream pretty early. I was really tired. Got, I think, 9 hours of sleep, so feeling very refreshed. Basically, we were looking at Micron's 2024 Q3 earnings report, and didn't get to actually go through everything, so let's actually go back to this. Micron 2024 Q3 earnings. Okay. Yeah, I think the big story here was you're trading at, I want to say 105, 107 at the high. Now it's 85, so that's, I want to say, a 20% decline almost. And I think the biggest point, or the biggest thing there, was guidance, especially in the first half of 2025, was pretty soft. I think they were thinking, so Sanjay Mehrotra, if that's how you pronounce his name, Mehrotra, he was saying that the first half of 2025, the consumer memory market, so that's PCs, consumer electronics, industrial and automotive, and also iPhones, or just regular phones, smartphones in general. That's what I have here. Expects growth to slow in the near term, and then growth to accelerate in the second half. Oh, let me also pull up the Excel, and let me see if Allison, what is good? What is good? Thanks for joining. All right, let me see. Got one viewer, let's go. One viewer, let's go. Yeah, we were also building this out. So Q3 revenues for 2023. $8,709, and I do think they break it down actually by Micron SEC filings. All right, so they do have their quarterly report here, and I want to see, they should break it down by type, whether it's flash memory, NAND, or DRAM, and I think NOR is the other one. Okay. Call it percent change. Dollar change. Actually, I want to move this over here. Yeah, just so it's slightly easier for me to see. Let's take DRAM, NAND, and NOR. Okay, and oh, I see. So, let me bring this back. I know why I did that. It's because it aligned with the years. Okay, so I have a note there. I might have screwed up the years though. Okay, there we go. Now it's more centered. But DRAM, call this dollars, and 3-month ended. I want to say this is probably in millions. Millions. Q3. 6,400, 2,241, and 68. So, okay. And I want to say if we look at the memory market, apparently this is only 4% of the memory market. So this is 4% market. And I want to say 4% of the entire, so if you multiply entire memory market being DRAM, NAND, and NOR, okay, how do we find the entire market? So it would be X times 4% is equal to 8,704. So I think what we could do is take 8,704 and divide it by 4% to get the entire market. So dollar market. And this is also in millions. So what is this? $217 billion. It's a lot. I got 2 views. Let's go. Let's go. Okay. I don't know what the market share was back then. But yeah, everything doubled except for NOR. I keep forgetting what NOR stands for. NAND is used for solid state drives, so that's more of a storage, non-volatile memory product. Dynamic random access memory, that's a volatile memory product. So anytime you actually turn off your computer, everything in DRAM that's stored in DRAM or memory gets deleted. It goes back to storage. NAND, I want to say it's permanent, so you never lose your data unless you delete it. NOR, don't know what that means, gonna be honest, so need to define that again. Okay, so it's other, primarily NOR. Recognize at a point in time when control of a promised good is transferred to our customers in an amount that reflects the consideration we expect to be entitled in exchange for those goods. All contracts with our customers are short-term in duration at fixed, negotiated prices, with payment generally due shortly after delivery. From time to time, we have contracts with initial terms that include performance obligations that extend beyond 1 year. Okay, as of November 28, 2024, future performance obligations beyond 1 year were $141 million, which included customer prepayments and contract liabilities. Okay, so this is actually interesting. Customer prepayments made to secure product supply in future periods and other contract liabilities were $614 million and $907 million, respectively, of which $473 million and $766 million were reported in other current liabilities. The remainder of the customer prepayments and other contract liabilities were in other non-current liabilities. Okay, so I didn't know that you also have essentially these pre-sales. I don't know if that's what you call them. I think NVIDIA does this with a lot of their GPUs. They sell their supply before even actually having the product, which I think is what they're doing with Blackwell. So maybe this is a similar idea. And I want to say this is probably for their high bandwidth memory 3rd generation. I think that's what they're on. HBM3E, which 473 million and 766 million were reported. Okay. Included 301 million from shipments against customer prepayments and other contract liabilities. I guess this means that 301 million of the pre-booked revenue were actually fulfilled. Okay. So this is also how they break down their revenue. The compute and networking business includes memory products and solutions sold in data center, PC, graphics, and networking markets. Okay. So memory products is probably DRAM, SSDs, and component level storage solutions sold into the data center and consumer markets. Includes memory and storage products sold in the smartphone and other mobile device markets. Embedded business unit includes memory and storage products sold into the intelligent edge through the automotive, industrial, and consumer embedded markets. Consumer embedded markets, I'm gonna take a guess and say that's anything that's smart device related. Could be a fridge, TV, maybe even a Google Home type product. I think any electronic device, any consumer electronic device is probably going to be using memory at some point. Okay, so let's do by segment here, and we'll do CNBU, SBU, MBU, and then EBU. But we'll also define. So CNBU, compute and networking business units. Okay, and memory products and solutions. I don't know what the solutions are. Sold into the data center, PC, graphics, and networking markets. CMBU. Okay, the other one was SBU, storage. SBU, storage, business unit. Okay. SSDs and component level storage solutions sold into the data center, PC, and consumer markets. Right, and then mobile business unit. Right, I remember going over this at some point, and then I just completely forgot about what this was. Storage products sold into the data center, PC, and consumer markets. Okay. And embedded EBU, embedded business unit, memory and storage products sold into the smartphone and other mobile. Oh wait, no, I was reading the wrong one. Into the intelligent edge through the automotive, industrial, and consumer embedded markets. Okay, so it seems like this is their biggest segment, the compute and networking business unit. That makes sense, I think, with all this AI stuff going on. Historically, in 2023 is also I think I saw that 20 outdated drivers. Oh well. Everything was operating on the loss though back in 2023. I wonder why. Okay, stock-based compensation. Maybe that was the big thing there. All right, Q3 4395 1731 1527 1052 and call it all other. All right. All other, so that's around 4. Compute networking, storage business unit, all other. So about $4 billion. I wonder how much units that is. I'm gonna take a look. Okay, so I know Samsung SEC filings. I know Samsung is a big, I'd say #1 memory maker in the world. SK Hynix, I think, is #2. I wonder if they break down. So that's July to September. It's not the same, but pretty close. Okay, PDF. I'm assuming this could be it. AI conventional server demand was strong. Assuming that's networking. I don't know what MX means. Mobile? Okay. Earnings results Q2 fiscal year. Let's see what this leads us. For servers, eSSD more products. I'm not sure what eSSD is. Fornex. Okay, AI server memory continued to rise. So 32 gigabyte, double data rate, 5 DRAM memory. I don't know what this stands for. MCRD IMM. I feel like DIMM, I want to say, is some type of memory bus. I forgot exactly what it stands for, if that's actually it. Okay, they don't break down revenues, it seems like. Turning to profit for 2 straight quarters. Okay. So let's see what did I download? Oh, here we go. Maybe this is helpful. balance sheet, their income statement. Okay. Oh man, it sucks because I can't really tell the exact percentages. Sorry, not the exact. Oh wait, they do give you the exact percentages. Okay, I'm tripping. So this is Q2 24. I wonder what period this is. Oh, okay, they do have a Q3. Let's take a look here. Q3 earnings. Yeah, I'll just say this for now. But let's break this down by, so SK Linux, and we'll do won, so KRW, Korean won, billion. Okay, yeah, I don't even need that, so DRAM, and then NAND, other. So it's 28%. Okay. Just copy this real quick. Q3 2024. So let's do 69% DRAM, 28%, and then take 1 minus 2%. All right. Just double check, just sum everything together. Should get 100. Okay. Now we can break down to okay, so now we could take the total and we'll do 17,573. Just take the DRAM, multiply this by okay. And now we have to convert to USD. Let's do like a conversion. So if I want to convert from Korean won to USD, do I take the KRW over USD cross? I'm pretty sure I want the USD to Korean won cross. And I divide that by, I can divide this number by I could take this number, I'm pretty sure, and then divide that by the USD to KRW. So USD to KRW exchange. I think there's like an exchangerate.com. Oh wait, maybe exchange rate history. So when was this released? I think it was October, right? October 2024. Let's just, yeah, let's go like October 31st. So 1379. Oops. Just gonna make a note. What we used. October 31st exchange rate. Okay, and then now we have, say, USD. Oops. Okay, nice. All right, so total. So let me try to remember, what was Micron's again? Micron, I think, was around around 8 billion in sales. Let's double check. Yeah, 8.7 billion. While SK Hynix is around 12.7. And the DRAM market, so $8.7, while Micron is around the 6 billion, 6.4 billion. Huh? So maybe it's not that far apart. It seems like Micron actually is Micron historically, I mean, it seems like right now they're not too far apart. Just around 2 billion in sales. But maybe with Samsung is probably a lot higher than both of these combined. Maybe not combined, but okay. Q3 2020. Ah, shoot, I keep doing the wrong one. 67%, and then other. Okay, nice. And then 16423. That's the number 9066. Okay, so DRAM. I think what we could do is maybe take this number and multiply by this. Yeah, maybe there's a faster way to do that. Okay. And then get the exchange rates. I'll get the USD number. All right, I'm just gonna make it simple. So 3 months before October will be October, September, and August. Yeah, let's just say it's October 30th, September 30th, August 30th. I know they released it in July though. Yeah, let's do July 31st. It's about the same, yeah. 1384. July 30th, 2024. I'm gonna trust this Wise thing. And then let's just use the same. So I think this is November, right? November. Oh, October, okay. Yeah, I have terrible memory. October 31st. Okay, 1,347. Same thing, 2023. Okay. Let's change this to J. Okay, nice. I'm gonna grab some water real quick. Let's see how the stream is going. Let's go. We got 3 views. 3 views. Not bad. Alright, I'll be back. Back. So year-over-year growth, it's doubled. So revenues have doubled. Almost doubled, okay. I think if we overlay the stock price, that would be an interesting graph to look at. Okay, Samsung. Right, Samsung business units. Device experience, visual display. Samsung life insurance, very interesting. So device experience or device solutions. Okay, so the memory business. Okay, 10.53. So I'm gonna double check what are the units here. So this is billion, billion one. $22. Oops. So I guess this will be 16 trillion won. This is 22 trillion won. Korean billion. Yeah, we can convert it into billion. Memory. Convert this into USD. Oops. $16 billion. So I think then if we sum everything up, 16 plus 12. That'll give us 28, and then plus 8. That'll give us like 36 billion in one year. 8.7. Oops. Right, so that's divide this by 1,000 and we'll add $37.6. You know, it's interesting, right? Because I feel like if you look in NVIDIA's earnings today in their business model, their data center segment alone brought in $28 billion. I want to say around that $28 billion range for the most recent quarter, 2020, Q3 2023. Or was it Q2, NVIDIA earnings release? November 20th, so this is a while ago. It was a record 30 billion, okay. Damn, I had no idea that they had reached 30 billion by that's just $7 billion away from the memory market itself. Huh, okay. I wonder if Samsung will It doesn't seem like it, but I want to see if they break down the memory. Sales by type. So it's the biggest segment. Mobile, it seems like, is their biggest segment, just by looking at the graphs. And then also server kind of looks the same. Okay, this doesn't really tell me much. I guess except for that percent in the earlier one. Let's see, maybe like Samsung 2024 Q3. Let's call transcript. Solutions, AI and the data creation. Keep memory demand robust. Okay, get all around 2 nanometer process. Other macroeconomic. Okay, so I think this is actually pretty consistent with what Micron has been saying. Demand was relatively soft. I don't know what inventory adjustments by customers and supply demand situation was. Maybe that's like customers marking down their inventory. Depleting aging inventories. We expect the trends experienced in the third quarter to continue in the fourth quarter. Specifically, while demand for AI is likely to remain strong, we expect some mobile customers to continue adjusting inventory from the previous quarters. On the other hand, we will continue to monitor other factors. Okay. We are flexibly rolling down our production for some legacy DRAM and NAND products. Maybe that's DDR3, DDR4. In line with market demand, in order to accelerate the conversion of cutting-edge nodes into our legacy lines. I don't know what 1B nano is. So in addition, we will secure leadership on high value added products with mass volume business of 10.7, I think it's like gigabytes per second. Maybe that's like the measure of throughput, how much data you can transfer per second. I want to say LP, low power, double data rate 5. I don't know what the X stands for. And I don't know what GDDR7 is. For TSG, yeah, not sure what that is. TCI Gen 5. Plan to mass produce a 64 terabyte. Wow. Excuse me. Okay. So 2025 outlook. Seems pretty consistent with what Micron is saying. Basically, AI and server demand is going to be pretty high. It's per box increase. We expect a gross momentum in demand due to the continuation of Windows 10 service. Okay, so that's kind of similar to what Intel, AMD have been saying on the client segment. They've been pushing this Windows and AI PC refresh cycle. So I guess for PC makers, or I guess logic chip makers and designers, they probably benefit the same compared to memory makers. Every computer needs memory, every computer needs a logic chip. So I guess that's probably the way it works. We expect the demand increase to be driven primarily by high density and high-end products based on cutting edge nodes rather than legacy products. Okay. Expect production degrowth to be limited. Okay, so I guess they do consider double data rate for a legacy product. Okay, I want to ChatGPT some of this. Hello. This is a piece of the Samsung quarterly earnings call. Can you explain what inventory adjustments mean? What does it mean when mobile customers are adjusting inventory? Okay, I'm gonna trust this, but basically what this is saying is inventory adjustments by customers is basically those customers being mobile device manufacturers. So probably an Apple, I guess Samsung is one of them, or maybe a Google. And they are actively deciding to hold off on purchasing probably legacy products, so anything that's double data rate 4 or below that, or older than that, I should say. they're probably going to hold off from buying those things and work through their existing inventory. So maybe the adjustment is referring to adjusting their demand for actual products that Micron, Samsung, SK Hynix will make. So it's probably maybe a simple way to put it, and I'm kind of happy with that. Decrease to reduce reversal of inventory. Okay. See if I can just search up Samsung Q3 DRAM sales. How are they getting the 10.7? Okay, then let's take DRAM 15.4. I like the emojis. Okay, I do think that Micron, Samsung, and SK Hynix all have an IDM setup, so they both design and produce their own memory chips. Okay. DRAM, Fortune Business Insights, Straits Research, oops, set. Oh man, okay. Okay, yeah, maybe these are kind of like the big memory makers. So, actually create a new list. Memory makers, chip companies. I'm surprised. Okay, I was about to say, I didn't see any Japanese companies. I know back in the 1980s, that was a big thing. Japanese memory companies. SK Hynix, Elpida, Transcend Information, Nanya, Power Chip, Winbond, Infineon, Kingston. Okay. Okay. It's a gaming console, mobile phones, PC, automotive. Yeah, I'm surprised they don't have servers here. What's this? SK Hynix. Yeah, maybe DRAM exchange. The DRAM spot price. What is this? More? Oh man, okay. Okay, I might be able to actually just sign up for that later. Okay, I might be missing something because why is this? Oh, contract price. I'm not too sure exactly what the difference is between contract price, but the spot price, I guess, is what you could buy today. And I don't know. Historical chart? Oh, shoot. Okay. Capacitor stores the bits. Transistor. Okay, is this consistent with what we have here? Yeah, Q3 2023. All right. I guess 3D DRAM is probably the high bandwidth memory. Right, so one massive interposer chip. I think that's kind of like the base floor of the entire stack. Okay. I'm gonna take this at face value and just say that this is probably right. I'm gonna copy this. So if we get USD, total, call it DRAM. So back in 2023 Q3, 5250. million USD. Okay. Let's do million. Okay. Times 1,000. Right, okay. This was 45300 and second quarter. Okay. I'm trying to think. Back in 2023, ChatGPT was released in November 2022. So I'd say it's probably around Q3, somewhere between Q3, Q4, and okay, probably Q4 then of 2022. So it's been almost a year, maybe 3 quarters. It's passed. And I want to say, I think the H100 was released by then. And I want to say the H200 was released too. I'm not entirely sure. But then I think one question I do have is, if in the server space, is it, let's say, a hyperscaler like AWS, are they the ones that are going to spend the money to buy the server memory and maybe the high bandwidth memory for their AI systems, or does it come bundled by like a super micro? I think they're the ones that actually sell the entire server box. I know NVIDIA, they did announce something with Micron. I think it was they verified Micron's HBM3E to actually work alongside the Blackwell system. So I think that's the kind of the stamp of approval from NVIDIA saying, if you're going to buy Blackwell, you should also buy some sticks of high bandwidth memory that Micron makes. But I think NVIDIA has had that stamp of approval, not just for Micron, but also for SK Hynix, probably Samsung as well. Yeah, okay. I'm gonna use the bathroom real quick. Also charge my phone. I'll come back to this because I think this is an interesting discussion to be made. Let's see how the stream is doing too. Oh, Allison in the chat. Yeah. Okay, how long has this been going for? About an hour now. All right, not bad, not bad. Okay, I'll be back in a sec. get some water. Let's go back to the Notion and add like questions to ask. So who are the customers of memory makers? How does the revenue companies buy memory at the spot price? Is supply contracted out beforehand? Micron mentioned that they have pre-sales, or I don't know what the term is. Pre-sold supply. Just say that. DRAM. Snowing? It's snowing. Maybe it is in Clarksburg. Hey. I can't really see. Oh, I see it. Yeah, there's... Wait, let me see you outside then. Man, it's just raining here. It's not gonna be a white Christmas in College Park, unfortunately. Two distributors. Bluetooth data center customers. See, actually, when was H100 released? March 2022. Okay, so everyone was on the H100 for a while. I don't know how to mark it. Like, how do you mark that here in this spreadsheet? Maybe I'll say So all of them launched in the queue. Let's copy this. For now, I think this is good. Okay. So now we're starting to see the memory game really ramp up. And I wonder if I have a NVIDIA model somewhere. That can sort of estimate the data center revenues. DRAM, NAND. I think for SK Hynix, let's try to see if we can get the application here. Okay. Oh, this doesn't tell you. The revenue by application. Oh, god damn it. Maybe this? Low to mid single digit range next year. Okay. Let me open up another spreadsheet. So I think here I do have kind of like the estimated PC units in thousands. So I think it's about a million. So 280 million. Right. First time in a while. I don't have anything here though, unfortunately. Did I delete it all? Like the estimated PC units sell through? Because I know it has been declining for a while. So if I'm forecasting, I guess I did forecast a recovery in the market. IDC, they forecasted an even stronger recovery, but 2025, guess that's the base case. Gigabyte or gigabit DDR5. 70% sequentially.
Mm-hmm.
Oops. Okay. Okay, so 30% of revenues in the DRAM were HBM. Percent total. So it seems like it's 30% now.
Mm.
70% sequentially. So where am I looking for the? Looking for the 30% here. Oops. Shift N. Oh, there we go. So from the Q3 2020. Shipment volume of HBM3E. So it's greater than 70% sequentially. So it'll be x times 1 plus 70% is equal to 637. So I think we could discount it, right? Divided by 1.7. Okay. So this would then equal what percent of the total? 20%. So if it's 20%, it's about $1 billion increase, right? I'm curious. Yeah, no, this is kind of like I'm trying to think like what actual products use HBM. I want to say probably any AI accelerator. I'd imagine. So think, let's say NVIDIA's Blackwell Hopper, all of those probably use it. AMD's MI300. Intel, I think they have their Gaudi series. I don't know if that's actually a big thing though. So those are kind of like the four, I want to say, chip design products from like a traditional chip designer or chip manufacturer. Then you have companies like Grok, I think Tensor Torrent, that are also in this space as well. Traditional chip designers, I guess pure play chip designers, not traditional, but pure play chip designers. Then I'd say you have like the hyperscale code designers. So Amazon, they have their Trainium and inferential chips. I want to say Apple and Broadcom, they're producing something. I don't know what that something is, but apparently it's in the works. I think Azure, they have a few things. I don't remember the exact names, but I know they're producing something. Google has their tensor processing units, and Meta, I want to say, has their MTIA, training and inference accelerator. And I think all of those use high bandwidth memory. Yeah, I think. So let's create a list. AI accelerators. We'll call them pure play design, chip design. Name, company. How about that? Okay, NVIDIA. I think the Blackwell. I think either 100, 200, I don't know the exact name. And then AMD, I think it's the MI300. Intel, Gaudi. Grok, maybe? Yeah, I don't know what that one's called, so I'll double check, but let's do hyperscaler. Google, Amazon, TPU, Trainium, Frenchia, Meta, MTIA. I think Azure also has something. I know there's like a data processing unit. I don't know if that's something we should. Alright, this should be Microsoft. Yeah, and then let's say Apple. I'll go Broadcom too. I think Broadcom's probably making their own AI accelerators. Marvel as well, potentially. Yeah. I know I have a Notion page on this, so let's take a look at some of the notes that I was able to write. I don't know if I put it here in the semiconductors. No, I did not. Okay. Probably in AI then. Maya. So there was a Maya. Okay. Maya. Yeah, this is causing some problems, so I'm gonna just save this and then exit it out later. Go back to it. Cobalt 100. So, both are CPUs though. %70% since November 6th. Okay, and then ByteDance. Mechanistic interpretability. Pure play chip design. Okay. I guess my question is, when was the idea of AMD SK Hynix? Got it. So it seems like HBM3. So HBM isn't a new concept. First announced and developed by SK Hynix and AMD. Through Silicon Vias. Okay. Goal was to increase memory bandwidth, so higher transfer of data by stacking chips on top of other with Silicon Vias. So I want to say Silicon Vias. Those are, if you're thinking about a building, like building some type of skyscraper, those are the vertical beams that help connect each floor to each other. Okay, so 2015, HBM first deployed in AMD's Radeon R9 Fury X. Okay, high performance graphics card. Okay, and then skip a few so we get 2020s. What AI accelerators? So actually, do all AI accelerators use HBM today? Okay, low power DDR4. Okay. So let's actually take a look at who are the main customers of HBM. is it server designers? Dell Super Micro. Huh, okay. So I thought HBM was placed on the motherboard closely to the CPU/GPU. Are today's chips all system design, or today's designed system on a chip? Same package, chiplet based architecture. To the same die, so I guess it's like a single piece. Okay, let's take a look then. Okay. The 100 gigabytes per second of total bandwidth. It's pretty fast. Okay, it's kind of blurry, this photo. So if I could paste this in here. Okay, so this is where the memory's at the architectural level. So GPU, what's the SM? I don't know what that is. So memory controllers, I'd assume, probably allocates or is able to grab stuff from memory whenever you need, whenever you have an instruction that wants to execute something. L2 cache. Okay, I guess it's like a second level cache. Probably, okay, it can communicate between each other. And then you also have, so it seems like one of these, this is a Grace processing unit. I'm assuming that's what GPC stands for, or graphics processing unit. And this is a GPC, maybe like a graphics processor, and TPC is probably like a tensor processor. Okay, what is... This is an image of the H100 GPU architecture. What does the SM refer to? Streaming multiprocessor. Oh, warps. Yeah, I think I remember that from my computer architecture class. I want to say that's kind of like a... Okay, so it's just a collection of threads. I think the CUDA architecture is single instruction, multiple data. So you have a single instruction, let's say it's an add instruction, but you have multiple data points that need to be added. But I don't think there's an actual dependency on the data itself. So each SM has shared memory that threads can use to exchange data and reduce latency when accessing. For each load store operations, managing memory, touching its own cache. Okay, so where is the SM? Okay, so they're embedded in the streaming multiprocessor. Matrix multiply accumulate computational rates. I think matrix multiply and then you just add. That's the accumulate thing. Genomics processing. So floating point 8 and 16-bit calculations. 16-bit, I think that's casting scaling between 9x. 16-bit, it's 1,200. 1,024, that's 2 to the 10. I don't know what this number, yeah, like the total amount of numbers you can represent with 16 bits. Three terabytes per second of memory bandwidth. Caches large portions of models and data sets, some trips to HBM3. Support. So H100 grows the CUDA thread group hierarchy with a new level called thread block cluster. Cluster is a group of thread blocks that are guaranteed to be concurrently, okay. I think it's like maybe a block and then a grid. Those are units of threads. A level called a thread block cluster. Thread blocks are guaranteed to be concurrently scheduled and enable efficient cooperation and data sharing for threads among multiple system multiprocessors. I think that's what SM. Tensor memory accelerator that tensor cores more efficiently. Okay, so Grace Hopper 100. So what's TPC and GPs for an phrase cluster, texture processing cluster? CUDA cores, tensor cores, and other computational units. Streaming multiprocessors. Okay, I see. Got it. All right, I'm gonna use the bathroom again. Gotta go. Okay, so this is actually kind of interesting here. But so with this architecture, it seems like it's guaranteed. It's guaranteed to have 6 HBM3 stacks. And I do want to be able to copy this photo. Oh, okay, so this is the... Yeah, it might be worth going into this. Eventually. It's going to take a lot of understanding. I don't fully understand everything here, but I think it'll be interesting to learn more about, to understand a bit. Okay, so this, so we can copy it again. Still kind of ass. Maybe this will work. Okay, yeah, that looks a lot better. Okay, and HBM. Requirements. Okay, so yeah, I'm gonna Grace Hopper 100 AI chip. Maybe AMD, that'll be fun to go into. But yeah, let's take a look at this then. HBM requirements. So there's 6, if I'm not mistaken. Okay, and then let's see, NVIDIA 200 architecture. Probably is the same. So what changed? This is the Hopper architecture. Okay, so this is using HBM3. Generation, I'll call it. So 3 or 2E. 3E. SXM, PCIe. Okay, my guess is it's probably gonna be the same number. They just changed the generation. Okay. Yeah, I did see it said 5 instead of 6. That's what GPT said. Although I don't believe them. I don't believe GPT right now. Okay, so question mark. Not entirely sure. But let's take a look at the Blackwell NVIDIA HBM architecture. Technical overview. All right. Let's see. Memory. So 8x2 site. It seems like it's 16. I'm gonna 3E 16. So even more than doubled. Up to 16. Yeah, maybe, okay, maybe it'll be helpful for memory bandwidth. Up to 16 terabytes per second. Memory size, so 384 bytes. Okay, wow. It seems like this is like the ultimate. Oh my god. Jesus Christ. I mean, I have to admit, this thing does look kind of scary. I will try to take a snip of this. So I guess it's just a rack of 36 GB 200 NVL 72, so rack of 36 GB 20 super chips. Okay, so I will actually okay, so there's two versions. It seems like SXM and NVLink. I don't know what the difference, and I don't know what that means, to be honest. But memory-wise, it does seem to be the same. So 141 gigabytes, memory bandwidth 4.8 terabytes per second. Dynamic programming, okay. Oh. So why does it say 5 here, but it says 6 here? It's a form factor. So it's .6M5 or PCIe Gen 5, right? Gen 5. GPU to GPU. So it does seem like NVLink works with this too, but it does limit the 5 high bandwidth memory. Okay. Yeah, maybe ChatGPT knows. HBMs chips with PCIe and only has 5. Slow production colors, okay. Okay, interesting. So 5 to 6. For complete design for PCIe and SXM. Okay, so 5 to 6, I'd say it's probably good. All right. Does it say anything about bandwidth? Peak. PCIe SXM. So it seems like it's the same, right? Okay. Oh, it's L2 cache size. Ah, I see. So I guess it depends on the form factor you're using. So that then impacts the actual bandwidth or the high bandwidth memory, which generation you're going to use. Millie Rock on him. Millie Rock. Let's see, how is the stream doing? It's doing okay. We are at 2 hours. Nice. Okay. I might go eat soon though. I'm kind of hungry. All right, Intel up 2%. Let's go. Let's go. Let's go. although my MongoDB calls are cooked. Yeah, I need to rest my eyes. It's been looking at my screen for like 2 hours. Oh god. Do a bit of cleaning up. I'm tired. I'm tired. Trying to think. What have I done so far? I haven't touched Myspace. Probably gonna have to do that for the next stream. Wanna go eat soon. Don't know what I should go eat though. Yeah, I'll figure it out. Alright. Let's try to do another 30 more minutes and then probably call it this stream. $356 gigabyte HBM3E memory. Yeah, I guess it'll be helpful to year released. So November 2022, November 23, and I think Blackwell Super Chip probably in December. I'll just put it November 2024 for now. $256 gigabytes. Oh, I didn't even add that for, okay, the videos. H100. 6 terabytes per second. Infinity Fabric links for low latency AI processing. Accelerated processing unit combine the power of AMD Instinct accelerators. These specs. Okay. SXM. 41 gigabytes. don't know what the memory interface means. Infinity architecture. Cool graphic, I have to say. I don't know what's going on though. I'll copy this link. This actually is somewhat interesting about how the architecture looks. MI325 X accelerator, 8 AMD. Where is this 2 referencing? Footnotes. Okay. HBM generations. HBM1, HBM2, HBM2E, HBM3, HBM3E. HBM generations. Then let's call like sizes. .2 gigabytes per second. Okay, so 8 divided by 24, I guess it's 3 gigabytes per, I don't know, what do you call it, per level? So it's same thing here. I think you're just stacking 12 instead of 8. Okay. Yeah, this is gonna take a while to build out. Seems like 2020, 2023, 2024. And then maybe we could do like a specs. So specs. All right, HBM 3E. Call it type 8 stack. What do they call it? 8 high. Maximum memory. Max memory capacity. It will be 24 gigabytes. Right? This will be a 36 gigabytes. So products. Implementations maybe. NVIDIA H200. Actually, let me, before I even get to that, probably helpful to, so max memory capacity, maybe bandwidth, tensor core GPUs. Okay, well, maybe, yeah, what's the data rate versus bandwidth? Right. Bandwidth. I think this is more important, okay. .2 terabytes first. Formula bandwidth is equal to data rate times bus width transfer per second. So what is a pin memory? So maybe it'll be helpful to watch the branch education. video for this. Maybe each of these black things are a memory pin. So there's a pin for each address. $1024 IO pins. .2 gigabytes per second. Okay, so it's actually pretty good to know. Bandwidth is equal to data rate times bus width. Data rates is measured per pin. $16 independent channels and 32 pseudo channels. I'm not entirely sure what that means. Offers 24 gigabyte. Okay. Let's do HBM2. So my thinking is, I would imagine SK Hynix, Samsung, the bandwidth and memory capacity is probably the same. Okay, right, so SK Hynix, they also have the 12 high. Okay, so it seems like when was this? September 2024. So September 2024, SK Hynix said that they're releasing 12-layer HBM3E with memory operations. So I guess this is the data rate of 9.6 gigabytes per second, gigabits per second, I think. Okay, so Micron. Let's do SK Hynix. .3E. It's the same here, it seems like. Data rates 9.6 instead of 9. Oops. Do you want to add? Okay. Oh, I think centralized metal oxide, silicon packaging. Okay, so 8 high, data range. Huh. Okay, so they first started with 24 gigabytes of capacity. All right. I don't know, like process technology maybe. That would be a cool thing to add here. Picojoules. Okay. I know this is an Excel graph when I see one. All right. One beta process node. Not too sure what that is. Yeah, I'm gonna put that there. Okay, yeah, I'm not sure what any of this means, but the TSV, so the through silicon vias, MR, MUF. By end of the year. Yeah. Let's go. Let's go. Let's go. I'm tired. I'm hungry. Let's see how this stream is holding up. We got 1 view. It's only been 4 minutes. No, it's been almost 3 hours. Okay. We've been doing good. We've been doing good. 5 views. Let's go. Let's go. Let's go. Okay, so Samsung HB3E. I think I'll end with this. See what Samsung's cooking up, and then I'm gonna go eat. I'm so hungry. So hungry. HBM3. May 8th, 2024. Okay. So very similar. Okay, it seems like 8 high, 12 high. So same thing, but this time they're going with claiming 9.8 gigabits per second. HKMG, so it's high K metal gates, and then MR, MUF, TSV through silicon via. Yeah, I don't know what. I totally forgot what MR/MUF is. Okay, so what is the Blackwell using then? Okay, I'm starting to get a lot of tabs, so I'm gonna delete most of these. Just to let my computer survive. Peak bandwidth of 1.22 TB per second. Okay, wait. So 1.22 divided by is equal 1.22 or 2 times 1,000 times 8 divided by 9.2. Do the same, but now instead of 9.6, 1.22. So it's slightly smaller. What I was trying to do is find if there's a common data bus width. Right, because I took the number of terabytes, multiplied it by 1,000. So that should be in gigabytes per second. Then we multiply by 8 because there's 8 bits in a byte. And then we divide that by the gigabits per second. Same thing here. But no, it's not the case. Peak bandwidth of 9.83. Oh, wait. Yeah, I'm not entirely sure. Okay, so MI so there's MI 325, that'll be 3E, memory size, so that'll be 244 gigabytes, right? That's what it said. So take this, divide it by 36. Oh, wait, it's 244 divided by 6 to 7. Okay. Divided by 24, be like 10 point something. Mm. 36.7 6 plus 4. Okay. What is the optimal times 5 times 2 is 3. Maybe a mix of, yeah, I don't think we can ever get okay, yeah, I don't think that's gonna work out. Memory size, memory capacity. Okay, that's exactly what I was trying to figure out. Okay, so not everyone gets it right. Not everyone gets it right. Let's call it 8 for now. HBM stack. So H200, I think, use the 8 high. 12 high probably. Okay, so with that, I think I'm gonna end this here. Actually, okay, Meta MTIA. Curious. How are they building that? So it's SRAM. PyTorch MTIA. So maybe it doesn't use. So it says here on chip memory, 2.7 terabytes per second. I think this is probably going to be high bandwidth memory. Let's... TCO, I feel like that stands for something important, like total cost of ownership. Okay, so AWS Inferentia. So it uses HBM. So lower memory or high bandwidth memory. Interesting. Okay. Yeah, now I will say goodbye. I'm very hungry, so thanks for tuning in. This is a fun deep dive into high bandwidth memory and the market today. Micron seems to be in a pretty good position. And maybe the sell-off is unwarranted. So it is recovering. 88. I think this has been kind of like the bottom for a while now. Let's see, year to date. So you'll see sort of this cyclical, I guess, maybe in one year, 5 years. So at the lowest point, 2020, was at $51 per share. $88 per share. Right, 58 to 80. That's more than a 50% increase. I guess interesting story there, right? Wow. Okay. I have to keep a lookout. Keep a lookout for all this stuff. It's hard to convert this back into what the market thinks. That's definitely a challenge and something to look out for. But with that being said, I'm gonna call it here. Thanks for tuning in, and I'll catch you guys in the next one. Peace.